In this video, we talk about transaction management system, where if on the database thousands of users are operating on a database, then how to process those actions of all these users simultaneously without affecting the performance of the database in terms of consistency and speed. Now, we can find out so many examples from our real life databases where we are booking tickets on IRCTC railway reservation system or aeroplane booking systems, flight booking systems, and your e-commerce sites where you are on a particular date they will announce huge sale, and all these users are simultaneously operating on the databases. Then how do we from the database point of view, how do we manage those actions of thousands of users simultaneously? That is one aspect. And the other aspect is from the end user, what should be the feeling of the end user for using this database, in terms of say consistency, in terms of his actions, and in terms of his speed of action and reliability of the system. All these things comes into picture in case of transaction management. And in this lecture, we'll talk about three aspects. One is how do you define a transaction management system in case of a DBMS, and what are the properties of these transactions, and given any transaction, in what states it can be in, so that we can operate on the databases in terms of thousands of operators or users operating simultaneously on the database. Day-to-day life, we are dealing with so many databases. If we again go back to the IRCTC or any other reservation system, typically what we are doing there is we are inquiring. First, we are trying to inquire whether the ticket is available or not. Then once we know that ticket is available, then we are trying to fill in our personal details. Once the personal details are filled, then we are trying to financial details, and once they are validated, we are trying to book the ticket, and we are getting a ticket. So in this process, there are several actions are there on the database from the end user. Similarly, if you go for e-commerce sites also, there are so many steps. First, you are searching for the products. Then once you are satisfied with the product, then you are trying to put it in a basket for buying. And once your buying process is over, then it is getting dispatched. So all these things involve so many steps. Then what constitute a transaction? What constitute a transaction, that we need to understand here. So typically any transaction is a specific sequence of operations that are accessing data for possible reading or for modification or writing of the data onto the databases with a meaningful outcome. That is important. With a meaningful outcome is also important. So that should have a specific target or a specific goal towards for these actions that constitute a transaction now. For example, if you take a transaction of money transfer, if you take transferring 50 rupees from account A to account B, if you take, then what are the actions that are involved in this process? First, we need to read the value what is there on the database. Then you subtract 50 rupees from account A, and then you replace the modified value in place of A, and then you read the value of B, and you add this 50 rupees to B, and then modify the value of P. These are all the actions that are taking place for transferring 50 rupees from account A to account B. Typically, this can be treated as a transaction because it is involving actions and with a specific purpose, with a specific meaning, right? So now we talk about a transaction as a specific sequence of operations that are accessing the data items either to read or modify or write with a meaning, which constitute a meaningful outcome. That's how we define the transaction. And we need to address so many issues in these transactions. What happens if a transaction fails? How do you deal with these transactions if it fails in the middle? That we need to understand, one aspect. Another aspect is, how do I make them parallel? Or shall I have to wait until another transaction is getting processed. Can we make them parallel? Is an issue. Now we are going to talk about these two issues in detail in these lectures. Talk about the properties of transactions. The first property of any transaction is atomic. The transaction should be treated as atomic. Though in a transaction there are several actions or steps involved in a transaction, we treat every transaction as an atomic unit, that is indivisible unit. That means we treat either the transaction is completed or not started at all. For example, in this case, there are 6 steps in the transaction of transferring amount from A to B of 50 rupees. But if you look at the steps, if all the 6 steps are complete and the transaction has stopped its action, committed its action, then we say that the transaction has taken place. That means the transaction is atomic. Suppose if at third stage there is a failure and the transaction has stopped, then we don't treat half of the transaction. No, we should throw out all the actions that of the transaction so far, and we have to restart the transaction afresh. That means as far as the database is concerned, we are treating either the transaction has committed, done all its action, or not done at all. That is what is called atomicity. So on a database, even if there are thousands of transactions taking place, for every transaction, either we should treat it as an atomic one, it is complete one, or not done at all. That's how do we treat the transactions on a database. That is called atomicity. The second property is the consistency requirement. Consistency in the sense, whatever actions that the transaction do on the database, they should be consistent with respect to the data and with respect to the actions of the transactions. Again, in this case, at the third stage, if there is a failure, then what happens? 50 rupees is debited from account A, but they are not credited to account B. Then at this stage, if you leave the transaction, the database is in an inconsistent state because 50 rupees debited from A, but it is not credited anywhere. So it's in the air. So it is inconsistent state. So before the start of any transaction, the database should be in a consistent state. And after the completion of the transaction also, the database should be left in a consistent state. That is a second important property of any transaction. Consistency, there may be several other types of consistency, not only the data consistency, but also with respect to the primary keys and explicit integrity constraints that are holding on the database, and all foreign key requirements. All such requirements should be met consistently even after the completion of the transaction. And before the start of the transaction, the database should be consistent, and after the completion of the transaction, the database should be in a consistent state. But when the database is running or the transaction is running, then there may be inconsistency seen temporarily in the buffer. But once the transaction is complete, there should be in a consistent state as far as any transaction is concerned. And if there is a logical error in the operations of the transaction itself, then there may be an inconsistency may arise, but the end user has to take care of using that transactions, or the application programmer has to take care to process them. Otherwise, any transaction should leave the database at any point of time once it is complete in a consistent state only. And the third requirement is durability. That means once the transaction is over, then all the actions of the transaction should be durable. Durable in the sense they should be available at any point of time even after the completion of the transaction. For example, in the same example that we have seen, the transfer of 50 rupees. This action of transferring 50 rupees from account A to account B should be permanently noted in the database. At any point of time in future, if I want to know at what point of time this 50 rupees has been transferred, I should be able to know. That is a durability. Unless some modification is done on that, this value should be consistent. Not only consistent, they should be durable also. All these actions should be permanent on the database. Another requirement of transaction management is that isolation. That means every transaction should feel as if it is the only transaction that is occurring on the database, and as long as a transaction is in progress, none of the values of the database objects that it is accessing should be getting affected by any other transaction. So that's what it means. It should feel as if it is the only transaction that is occurring on the database. Then how do we achieve this? We can achieve isolation in one way by operating the transactions in a serial order. The order in which they enter the database, one after the other, if we process the transactions, then definitely we can achieve this isolation. But can we do that is a different issue. What are the effects of doing that is a different issue. We'll talk about that later, a little bit later. Now, what happens if I allow another transaction to do actions while one transaction is running? That is simultaneous operation of the actions of the transactions. In this example, if you look at this, after the third step, if you allow some other transaction to read A and B and print the value, after that transaction 1 is again completing its action, then what about the values of A and B? The value of A is from transaction T1, but the value of B is before T1. The value of B read by T2 is before T1. But T2 has entered after T1. It is supposed to read the value that is written by T1. But because of the mixing of these operations, it has read an inconsistent set of values and the output is wrong for T2. So this is because of this inconsistency arise because of the isolation is not met. The database objects are getting affected by some other transaction. So isolation is not there in this case. Now, two issues. If you operate the transactions in a serial order, then definitely we are going to achieve all these consistency and isolation requirements. But in a real-time situation, can we do that? What happens if I do that? The 100th transaction has to wait until all the 99 transactions are completed, and that requires a huge time. So throughput of the system is an important issue here. How do I maximize the throughput of the system? Throughput of the system in the sense, number of transactions that are getting operated or finished per unit time. So this throughput is also important. And while executing these multiple transactions concurrently, we will have a significant benefit. In the next part, we will observe how to achieve that. The states of the transactions are depicted in the pictorial form here. Once a transaction starts, it goes into the active state, and once the transaction is performing its actions or instructions one by one, gradually it may reach a partially committed stage if all the actions are complete. Or if in the middle, if after performing certain set of operations, if it fails, then it reaches a failed stage. So there are two possibilities. Either the active transaction can reach a partially committed stage or a failed stage. Now, if it reaches a partially committed stage, again there are two steps. Either the transaction is committed, that means it is transferring its contents onto the hard disk. It's a committed stage. Or even at this stage, though the actions of the transactions are complete, before committing, the transaction may fail. There are so many possibilities of mechanical failure or hardware failure or whatever the failures occur. So now, again from partially committed stage, there are two possibilities. Either it reaches a committed stage or a failed stage. Now, once it reaches a committed stage, then it may end. It may end. That means it has transferred all the contents of the contents onto the permanent memory, and there is a confirmation from the permanent memory to the buffer manager that the writing is complete. Still, there may be a possibility of failure in this case also. Even in that case, it goes to the aborted stage or a failed stage, of course. That is not depicted here. It may go to the end stage. Similarly, if it is in failed stage, if the transaction has failed, then we have to abort the transaction. That means we have to treat the transaction has not entered at all. That means we have to throw out the transaction from the database. And it has to restart once again from the active state, beginning stage itself. That is what is called abortion stage. And once the transaction is aborted also, it is treated as ended and it has to restart again.